Hello everyone. In this session, I will be covering basics of PyTorch Tensors. So you can visit pytorch.org and you can find all the tutorials which are related to tensors and all other things which are related to PyTorch. So I mean you can follow along this particular tutorials, and where you can try out different examples which are provided here. I will be covering only the basic stuff, so that you can directly from your you can go to this site and you'll not find any issues in following all the examples which are provided here. So I'll just cover only the basic things here, and few examples I will be covering related to creating of tensors. I will not be covering any tensor operations here in this session. So we'll start with importing the torch library. This is the torch package, and after that I will importing the numpy also, because in I will be creating uh, PyTorch tensor using numpy arrays also. And in the third line here, third statement, I am printing the torch version which is there in the Google Colab, which I am using for this session. Okay, so I will be executing this first cell. Okay, let's execute this cell. Okay, 1.8.1 is the version of PyTorch. This is the latest version which is available. Okay, so we'll start with creating a tensor using the numpy array. So in the first I will create a numpy array, and then we are printing the numpy array here. And from numpy array we are creating a, in the third statement we are creating a uh, tensor and using from numpy method, right? So then again I will be printing the tensor also, and the because tensor also has some attributes. One of the attributes is data type. So what is is a data type, like it's int 64 or float 32, or you know. In this case, let's see what is the data type it is printing. Will be the default data type, and these are all the integer value. So the default is here is the int 64. Let's see. Okay, fine. So here is the initially it's the NP array. It is printing. These are the values of the NP numpy array, and from that we have created one tensor. This is the tensor, and this is the uh, basically this is the data type int 64. Okay, so this is one of the ways for creating a tensor from numpy array. Okay, we'll go to the next example where we'll uh, initializing or creating a tensor from some another tensor, right? So here, okay, we have in the first example we have created one tensor from numpy, that is example one. Here we'll be creating a new tensor from example one, and this time the data values which we will pass for this particular tensor will be all ones. Okay, so here the tensor will be created like torch.ones underscore like, and in the bracket we are specifying example one. So it will be tensor will be created like the tensor which we have created earlier, that is example one, right? But the values will be all ones, right? So let's execute this particular cell. Okay, now you can see that values will be all ones, because this is a function which was not ones we are using, but the data type which we have, which is created in 64, because same data type which is created, and the shape of the tensor which is created is also the same as the example one. You can see. Okay. Okay, let's move on to the next example. Here we are specifying the data itself. So here we have created tensors from numpy array and using some another tensor, now we are creating directly using specifying some data. Again, tensor is the method which we are from which we are creating tensors. This method. Okay, now in the second statement, we are we are printing the tensor and then the tensor attributes. One is the data type of tensor created and the shape of the tensor, and there is another attribute which is required. I will not be going to depth as of now. That requires gradient. This is definitely required when you start building the PyTorch models and you need to optimize your parameter and all that. So this requires gradient will be very helpful. That is another core strength of PyTorch. Okay, so just execute this particular cell and see what is the uh, values of all these attributes. Okay, so here the tensor is created. It's a basically it's a two rows and three columns. So you can see the torch dot size. This is printed using torch dot shape. Torch dot size is 2 in 3. So two rows and three columns, and this is a tensor, and this is the default in 64 type. And here you can see the requires gradient is actually false. So by default it is its value is false. So if you want its value is true, then you have to specify while creating the tensor that you want this value is true. I'll be covering that example also in later examples. Okay. Next, move to the next example. Here you can see that, and here I'm creating a tensor but with different shape, and now earlier you can see that I have created a tensor using dot tensor method with a small t. Now I'm creating a tensor using dot tensor method, but here the capital is using the capital T. This particular method basically will always create a tensor of type float, because this is an alias of the default tensor type float tensor, which is float 32. So this, using this, if you create a tensor, it will always will be created using the data type will be float 32. Again, I'm printing all the attributes just to show what is the details of the tensor which is created. Okay, so just execute this particular cell. Okay, and now you can see here that the tensor is created using float 32, because capital tensor T, this will always create the tensor with type float, and default is float tensor is float 32, the default value which is created. So there is a difference, because earlier when you have all the integer value, and when you created tensor, it is created with int 64 del type. But here, because it is a the alias of default tensor type, which is a float tensor, the float tensor is float 32. So that is the reason in this case the tensor is created of data type float 32. Okay, let's move on to another example. Here in this example, we are actually specifying the type which we wanted, data type. So we just pass while creating the tensor, data type is equal to cost of double. So in this case, we want data type as double, right? So again, we are following the same pattern to print all the attributes and the shape of the and the details of the tensor. So let's see. In this case, okay, you can see float 64 here. Double is basically float 64 type data type. So this is the tensor which is created. You can see what are the data types here in the documentation of PyTorch. You can see just okay. Here you can see double type. Say cost for double is 64-bit 14 point. This is the data type, right? And the default which we have created cost float tensor is float 32, which we have created in the previous example. Here, float tensor type is created float 32. Okay, so moving on to next example. Here I'm also printing the device type where this particular tensor is stored. And again I'm creating a tensor but the different dimension. It's 2 by 3. You can see. Uh, Sorry, it's 3 by 2 actually. 3 rows and 2 columns. 3 rows and 2 columns. Like 3. And here we are not specifies again type. So by default it is taking float 32. That is a default type because we have specified a floating point, right? So in floating point we have specified data. That is the reason the default is taking as float 32. If we specify integer values here in the while creating tensor, it will by default it will take int 64. Since we have specified here we have specified data as floating point, so the floating point default is float 32. So that is the reason that this tensor is created as float 32 data. And this tensor is on which device that we can print using tensor dot attribute is device. Here it is stored on CPU. So and again requires gradient false. That is the default value. This is a very simple example. Let's move on to the next example. So in next couple of tensor example, we will be creating some constant values, right? Like random. In this case, we will be creating a torch. This is tensor using some random numbers dot rand, and this is the shape which we have passed. Like it is say 243 shape of the tensor which will be created, and this values will be between 0 and 1 randomly generated values which will be created for this tensor. Let's execute this cell. Okay, you can see that four. See, this is a shape. Four rows, three columns, and there are two sets basically. So this is the tensor which is created. When you actually move, create a model, and you will have a image data type or other text. There you will find the higher dimension tensors also which we will use. So this is very it's very elementary kind of thing. So this is not a very complex tensor. This is very elementary when you actually start using uh, creating models with images or another text. Okay. So all these values between 0 and 1. So this function will create random values between 0 and 1. Now in the next example we will be creating a tensor with all 1 values, right? So again just using torch dot ones, and then in the argument we will passing the dimension of the tensor which we want. Okay, this is a tensor of type this shape, and we by default we require gradient will be false, and it will be on CPU, stored on CPU device, stored on CPU, and type is float 32, and this is the size of the tensor which you can verify here in the example while we are creating the tensor. Okay. All ones are there in the tensor, and similarly we can have a tensor with all zeros by passing our this method from zeros cross dot zeros. Okay, here you can see all zeros and float 32 again. In this case, all float 32. This actually float 32 is the default tensor type. So you can see that most of the time float 32 will be there, except when you are specifying all integers. Right. In all these examples, you can see that the required gradient is false. That is a default value. Right. So I'll set I'll not be grading this gradient stuff here in much detail, but I'll just show you some basic example like how this gradient come into picture. Right. So in this case, I created some tensors. The first tensor is basically without which actually means that the required gradient will be false for this tensor x, but for next two tensors I have specified required gradient as true. Okay. Now this is a simple operation which I have specified, tensor operation, like this is w and into x and w power 2 and plus some addition of b, another tensor, and then I'm calling dot backward method on the resulting tensor which we have created here. Okay, again, why we are calling backward, what is that I will be explaining when I will be explaining the PyTorch model creation. There you have to use the backward method. But just for simplicity, I'm just calling this thing backward method, and now I'm here in this next three statement. I'll be printing the gradient. Gradients basically differentiation, basically derivative. dy by dx is a x dot gradient, which is dy by dx. Y w dot gradient dy by dw. Y is this the resulting, and similarly b dot gradient is dy by dt. Now you just execute this thing, just you will get some idea like where how gradients are used here. Okay, where the gradient is false, where we have not specified required gradient is true, the gradient is actually coming as null. That is important thing, because we have not specified gradient here as 2, but for other gradient, because we have specified as 2, so we can find out the gradient values. Okay, so when we have specified, then you can calculate the gradient. So here the value which is coming thing, but if we specify here as false here in this case, so again the value will not be generated for dy by dw. We cannot calculate gradient. So for calculating of gradient, that requires gradient parameter value of the tensor should be true. So that is important. Again, there is one another type of tensors where you can create tensor is to uh, basically specify the dimension names to the dimensions basically. This is helpful, but this particular feature is still is an experimental phase, so I'll not go into depth, but I'll just show one particular example that this is a particular tensor which we want to create using a random method, right? So, but the fourth dimension which we have specified, we have given names to these dimension, like first batch, then channel, and height and width. These are typical image data which we use. So then in the print statement, we are actually printing the names of these dimensions which we have specified, and here we have just printing just one name. Okay. Okay. Now you can see that in using dot names, it just printed all the names which we have specified for the dimensions which we have for this particular tensor, and in one particular name is basically you are giving some index value, like here front index start with 0, one is the second index, so second index is channel, so that way it is printed as channel name channel. And you can see the warning that those tensors and their associated APIs are an experimental feature. So I'll not go into details of this particular type of tensors, name tensors, because this is still under active development, I guess. So when things will become stable, then we will cover in more details. So I hope that I covered some basic ways by which you can create tensors. So I just covered those things. And if you want more detail, definitely from here you will definitely go to the uh, pytorch.org. So where you can find details of other ways by which you can create tensor of different data types, or you can go into details about how tensors are stored or all other things. So definitely you can visit this particular uh, web page pytorch.org, and from you can carry on your journey of learning tensors and PyTorch. And that's it from my side. Thank you very much.